This is the final video for the Chapter 9 review. I'm going to do a couple of the graphing problems. Here are a couple extra notes. Although you already have these in your Chapter 9 lecture notes, you're welcome to take a screenshot of this page, but it's just a repeat of what you already have. So an asymptote is an invisible line where the graph gets closer but never crosses, and I'll draw it in a second as an example. A vertical asymptote you find by setting the denominator equal to 0. And you find a horizontal asymptote by looking at the leading exponents. So the examples in black are for horizontal asymptotes. So right here, right here, when x cubed over x squared, when the 3 is bigger than the 2, you're looking at the exponents, okay? 3 is bigger than the 2, you have no horizontal asymptote when the top is bigger than the bottom, okay? And then this example right here, when x squared over x cubed, when the bottom is bigger, like the 3 is on the bottom and the 2 is on the top, your answer is always going to be y equals 0. That's your horizontal asymptote. If they're the same on the top and bottom, like this one and this one, where the x, we're looking at the exponent, the squared over squared and squared over squared. So in the first case right here, x squared over x squared, you just divide. So you divide the top by the bottom and you get y equals 1 is your asymptote. And then over here, the 2x squared over x squared, you also divide because it's the same on the top and the bottom, the squared and the squared, so you get y equals 2. So that last case where the top and the bottom are the same, you're not always going to get a certain answer. You're going to divide and you're going to find out what your answer is, okay? And then the last vocab word is a whole. That's when an expression cancels out on the top and bottom, and you set that expression equal to 0. And your final answer for a whole needs to be in coordinate points like that, okay? So a quick drawing is, here is an XY graph, okay? A horizontal asymptote, HA, right? A horizontal asymptote looks like something like this. You're going to draw a dotted line like this. A vertical asymptote, vertical is going to be something like this, right? That's going to be an x equals. This, the horizontal was going to be a y equals something, okay? And then your whole would be like, okay, say we had a hole right here, okay, then our graph could look like, this with a hole right in the middle, and then over on this side, like maybe right here. Okay, so those are all your examples of an asymptote. Is the graph never touches the asymptote, it just gets really close to it, okay? And the final thing to do is to graph it on your calculator or on Desmos and see your work, okay? So see how the graph actually looks. Okay, so we're gonna go do a couple problems. We are gonna use this one. We're gonna do number 17. So number 17, is x minus 2 over x minus 3, okay, so, or x plus 3. So we are going to look at our vertical. First we're going to look for any holes. We're going to simplify this, and it doesn't need to be simplified. Nothing can be canceled out, nothing can be factored out, so we're good. We don't need to change it at all. So let's look at our vertical asymptote. Our vertical asymptote first. Okay, our vertical asymptote, remember, is the denominator, whatever is in the denominator, equal to 0. So we've got x plus 3, we set that equal to 0, and we subtract 3, and we get x equals negative 3, and we just leave it like that. That's fine. X equals negative 3, and then we draw it. So x equals negative 3, remember it's a vertical asymptote, so I'm going to zoom in to draw this real quick. On the negative 3 line, I'm going to draw a dotted line, and it's vertical because it's up and down. Okay, so that's my vertical asymptote. The next thing I'm going to do is a horizontal asymptote. Horizontal asymptote. And remember, we're taking the leading exponent. So the biggest exponent is this one right here on the top, and the biggest exponent is this one on the bottom. So we've got x over x. They are the same on the top and bottom, so what do? We divide them. So we divide x divided by x, and we get y equals, our answer is always in y equals for horizontal asymptote, and we get 1. X divided by x is 1. Okay, and then, so now we are going to zoom in. This is a horizontal asymptote, so I'm going to zoom in, and it's going to be horizontal. It's going to be a dotted line on the y equals 1. And now we have two asymptotes. And now I'm going to look, see if if I have a hole, which means is there anything on the top that can cancel out with the bottom? Like, is there an x minus 2 on the top and the bottom, or an x plus 3 on the top and the bottom? So there's nothing that cancels, so there are no holes. We're going to write NA, not applicable. And then we are going to graph our what we have now. So we are going to go to Desmos. We are going to plug in this equation, and we are going to see that the graph is over here, getting close to those two asymptotes, and over here. Okay, so you're going to plug it into your graph, and you're going to see that that's where the graph is, in those two corners, so that's where you graph it. Okay, and then the last one we're going to do, is number 21. So you guys can zoom down to 21. This one is a lot of work because it's not already put into a formula for us that we can cancel out. So we are going to factor. I'm not going to show all the work for it, so make sure you know how to do this yourself. The top, we can pull out a greatest common factor of 2x, and we get stuck with x minus 2 on the inside. Okay, make sure you know how to do that. And then on the bottom, I'm going to do, if you do a t-chart on the side, which I'm not going to do, I guess I can do it right here. We are going to get what? 6 times 1, which is 6. We're going to get negative 5. Okay, so a number that multiplies to 6 and adds up to negative 5, they're both going to be negative. They both need to be negative. Negative 3 minus 2 is negative 5. So our answer is going to be negative 3 and negative 2. So I'm not going to show all the math for that after that, but you're going to get 2. You're going to end up with x minus 3, x minus 2. You can go do the math for that to get the bottom to equal x minus 3, x minus 2. All right, now we're going to look at, let's start with our hole. We can see something on the top and the bottom that cancels, so we know that's going to be our hole. Our hole is, we're going to take that x minus 2, and we're going to set that equal to 0. And we're going to add 2, we're going to get x equals 2, and we need to remember that we need it to be in a point form. So we are going to, we need to plug in that 2 back into our equation, but we don't need to plug it into our original equation, we just need to plug it into what's left right here, okay? So we need to plug in that 2 back up there. So we need 2 times 2 over 2 minus 3. And we are going to get, for our y value, 4 over negative 1. So we are going to get negative 4. And so that is our hole right there. So we're going to go plot that real quick before we move on to negative 4. That's our hole. Okay? And then let's do our vertical asymptote. Vertical asymptote is whatever is left. What color did I do vertical asymptote up here? Red. So vertical asymptote is whatever's left on the bottom. We set that equal to 0. So whatever's left on the bottom is just this x minus 3. So we're going to set that equal to 0. X minus 3 equals 0. We're going to add 3. X equals 3. Okay, and I'm going to go over here, and it's vertical, so it's up and down. So I'm going to zoom in. I'm going to draw my dotted line on x equals 3. Okay, you guys should do that too. And let's see, horizontal asymptote is in what color? Blue, I think. So horizontal asymptote is you actually do take the original. You go look back at the original. You look at the leading coefficient for each. So we're going to look at this 2x squared and this x squared because those are the leading coefficients. It means they are the highest, or the leading exponents. Those are the highest exponents we have. So we have 2x squared, that's the highest exponent we have on the top, and x squared on the bottom. So the x squared and the x squared match, so we are going to divide the top and the bottom, and our answer is going to be y equals, all that's left is the 2. So we are going to sketch our y equals 2 right there. That's our horizontal asymptote. So we have a horizontal asymptote, a vertical asymptote, and a hole. All of those things. So we are going to go to Desmos. plug in the original equation, and we are going to see that the graph looks like this. There's something up here, and then down here, there is a graph like that, something like that, okay? And there's a hole right there at that spot. So make sure you do hole, look for a hole, look for the vertical asymptote and the horizontal asymptote, okay? And that's it. The rest of the worksheet is your homework.